All right, continuing our discussion of angles, we're going to add angles to the coordinate plane. And the standard convention is that when you're putting an angle on the coordinate plane, you put one leg here running along the positive x-axis. One leg goes down the positive x-axis. And if we're doing some angle in the positive direction, we move counterclockwise. So positive angles go this way. So this angle here is actually a 30-degree angle. If we go clockwise, it's 30 degrees, or if you're measuring things in radians, 30 degrees is pi over 6. So that would be a positive pi over 6. If we're going counterclockwise, if we're going in the opposite direction, let me change my pin color here to, I don't know, red, I guess. That's the standard accounting sort of thing to do. Oops, pen. There we are. Get the pen, get the color. Then if you're going in the negative direction would go counterclockwise. So this angle would be a negative 30 degrees or a negative pi over 6 if you want to measure things in terms of radians. All right, so positive directions go counterclockwise. Negative directions, negative is clockwise. And we start with 0 degrees here running out the positive x-axis. So 0 degrees or 0 radians, it runs along the positive x-axis. This would be 45 degrees. There's a handful of angles that are really important that we tend to see a lot. And it would be really nice if you could, well, actually the expectation is that you memorize their radian equivalents in here. So pi over 2 or 90 degrees is there. 60 degrees would be pi over 3. And 45 degrees is pi over 4. And 30 degrees is pi over 6. This angle all the way to this direction up here is 120 degrees. Or 2 pi over 3. Here is 135. 3 pi over 4. And 150 degrees. And that's the same as 5 pi over 6. 180 degrees will put us back on the x-axis, or pi. Radians, 180 degrees is equivalent to pi. That's what we standard use when our conversions. So that's a nice angle to know as well. This one would be 7 pi over 6, or 210 degrees. This is 5 pi over 4, which is the equivalent of 225 degrees. This angle down here is not 5 pi over 4, 4 pi over 3, or 240 degrees, 270, or 3 pi over 2, or it's also equivalent to negative 90 degrees, negative 3 pi over 2. So when we do this, we like to say that there's any measure you can angle, but there's multiple ways to describe a particular angle. One of the challenges is that there's there's multiple ways. So this would be 330 degrees or negative 60. No, sorry, that's 300 degrees. I'm getting ahead of myself. Come on. There we are. This is 300 degrees. Down here, 300 degrees, or 5 pi over 3. This is 7 pi over 4, or 315 degrees. This negative 30 degrees is also 330 degrees, and a positive 7 pi over 6. But as I was mentioning just a minute ago, is that there's multiple ways to describe angles. That depending on whether you go clockwise or counterclockwise, when you get to a point, there's a couple different ways that you can get there. You can even go all the way around once if you want to. This would be also, besides 30 degrees, it could also be 390 degrees, right? The 390-degree angle would take you all the way around and then back to that same point. So one of the challenges that we have is sometimes when you come across an angle, you have to do some scaling to find out where it would be back in the standard 0 to 360 or 0 to 2 pi uh, um, measurement, or even a negative angle in there as well. So of course, it's just adding or multiplying or subtracting multiples of 2 pi over 3. So as you go, again, counterclockwise, it's a positive angle, or going clockwise, it's a positive angle. Going counterclockwise, it's a negative angle. All right. So what we'd want is to look at a handful. So let me pull up what I want you to be able to be really familiar with in terms of memorizing angles and degrees and their equivalencies. Okay, so what I wanted you to, the angles that I want you to memorize, to just have at the top, that you can have the equivalent conversion into radians or super fast. I guess maybe memorize them. Of course, 0 degrees is the same as 0 radians. 30 degrees is the same as pi over 6. 45 degrees is the same as pi over 4. 60 degrees is pi over 3. 90 degrees is pi over 2. 120 degrees is 2 pi over 3. 135 is 3 pi over 4. 150 degrees is 5 pi over 6. 180 degrees is pi. 210 is 7 pi over 6. 225 is 5 pi over 4. 240 is 4 pi over 3. 270 is 3 pi over 2. 300 is 5 pi over 3. 315 is 7 pi over 4. 330 is 11 pi over 6. And 160 degrees is pi over 2. It might seem like that's a lot, but there are some nice patterns that develop. Basically, if you get the first quadrant down, if you get 0 through 90 down in here, then the rest are generally a lot easier to keep track of in terms of those. So let's kind of look at some of the patterns that we have in there. If I go back to my circle here, why am I not seeing that? Hope you're seeing the same thing I'm seeing here. Is that if you look at like a 30-degree angle at a pi over 6 angle, if you look at the pi over 6, what's going on here? Give me pi over 6. Oh, I'm using the wrong side of my pen. There, that works better. So here's pi over 6. And this one over here is 5 pi over 6. That if you look back, going to the back to the angle to the x-axis, if you've got a 30 degrees back to the x-axis from wherever you are, it's 5 pi over 6. And this one down here is 7 pi over 6. And this one is 11 pi over 6. 11 pi over 6. That if you're going back to the x-axis in terms of that measurement, it's a pi over 6 involved there. The 45-degree ones, 45 degrees is pi over 4. And then the same one over here, where you're looking at 45 degrees back to the x-axis, that would be 3 pi over 4. And this would be 5 pi over 4 down here, bigger than 180, bigger than 1 pi, but it's a pi plus another pi over 4. And then this one is 7 pi over 4. A pi over 4 short of being 8 pi over 4, which would be 360 degrees, 2 pi, or 180 degrees there is pi. And then, of course, pi over 2 is 90. Pi over 2 is 90. And then 3 pi over 2 is 270. So those two kind of go together. They're the right angle ones, the straight up, straight down on the y-axis there. Those are uh, pretty straightforward. And then the 60-degree ones, where you've got a 60 degree back to the x-axis, that's pi over 3 and 2 pi over 3. Both of those, if you go from that angle all the way back down to the x-axis, it's sort of a 60 degree. We call it a 60 degree reference angle. We measure back to the x-axis. We've got a 60 degree reference angle. And going from that x-axis out here 60 degrees, that is actually, well, that's 2 pi, that's 3 pi over 3, so this would be 4 pi over 3. 4 pi over 3, you're adding a pi over 3. Pi would be 3 pi over 3, right? 3/3 of pi, add another pi, you'll get to 4 pi over 3. And this one is 5 pi over 3 at that, what is it, 300 degrees, the 300 degree angle. If we go all the way around, it's 300 degrees. It's negative 60 degrees, but it's a pi over 6 angle back to this one over here. So if you look at all the thirds, all the ones that with the 3 on the bottom, they correspond to a multiple of 60, with the exception of pi is 3 times 60. Yeah, 3 times 60 is 180 degrees. So the 60 degree ones all have a 30 at the bottom. I'll have a 3 at the bottom. It is kind of backwards that the 60 degrees are pi over 3 and the 30 degrees are pi over 6. So that's a little bit backwards in there. But all of these with the 30 degrees, the pi over 6s, all and kind of in these bottom are these 4 down here that are pi over 6. So hopefully you can kind of look at some of those patterns. If you get the first quadrant down here, the 0 to pi over 2 down, I think a lot of times a little bit of thought and you can get to what the other ones should be, a little bit of reasoning. But it's important to have those equivalents C's down. Those angles tend to show up a lot, and so being able to flop back and forth between pi over 6 and 30 degrees and 2 pi over 3 and 120 degrees is really important. So please try to work on that. All right. And I guess that's it for this lesson, and we'll see you next time.